Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
Please allow me to briefly explain in prose, rather than in the notations and symbols of the partial differential equations that I scribbled on my blackboard, or rather green board, that was reprinted in 2 postage stamps of Nigeria. Those 2 systems of partial differential equations are the pressure and saturation equations, respectively. The conservation of momentum that corresponded to Darcy's law, or the linear relationship between the fluid velocity and the pressure head gradient, is encoded into the system of partial differential equations that is used to discover and recover otherwise elusive crude oil and natural gas. Please allow me a couple of minutes to present the pressure equation that is a grand challenge equation that must be used to discover and recover otherwise elusive crude oil and natural gas, and to present that partial differential equation of calculus to the research mathematicians and research physicists that are listening to this lecture. I will replace the mathematical shorthand and the sparsely written text that I used on my famous green board photograph that was on 2 Nigerian postage stamps, and replace both with their word substitutions. The research mathematical physicist that is listening to this lecture can translate my system of partial differential equations of calculus to the unabridged laws of physics. The pressure equation on my green board photo that was reprinted on 2 Nigerian postage stamps and in school textbooks and reports is this: the compressibility of the fluids, namely crude oil, injected water, and natural gas, as a function of pressure and saturation underscore S times the lowercase delta derivative of pressure with respect to time is equal to the source and sink terms Q subscript P, such as water injection wells, crude oil production wells, and natural gas production wells, that is a function of pressure and saturation underscore S, minus sigma, the Greek uppercase letter for S, that instructs the petroleum reservoir simulator to sum the elements of the sequence from subscript M equals 1 to superscript 3, where the elements to be summed is the product of fluid partial molar volumes V subscript Fm as a function of pressure and saturation underscore S, and nabla or upside down delta and the gradient operator, divergence of the summation of the elements of the sequence from subscript R equals 1 to superscript 3, where the elements to be summed is the product of chi subscript Rm, where chi is the lowercase x, that is the 22nd letter of the Greek alphabet, and where chi is the symbol that represents the fluid component densities, that is a function of pressure and saturation underscore S and nabla pressure. The governing system of partial differential equations can be written on the back of a postage card, but yet their algebraic approximations can only be accurately solved across millions upon millions of commodity off-the-shelf processors that were tightly coupled to each other and that shared nothing between each other and that occupied the space of a soccer field and that cost more than the budget of any of the 40 poorest nations in the world. For the impes, or the fully implicit methods, the implicitly discretized system of partial differential equations cannot be parallel processed across my ensemble of 64 binary thousand processors. For the impes method that solves pressure implicitly and saturation explicitly, these saturation partial differential equations are discretized with explicit finite difference algorithms.
Insightful and brilliant lecture.